guys. Now, here's what I want you to think about. Yesterday, we talked about exponential growth and decay, right? Yes? Okay. No, I just want you to look up here for a second, all right? So, y is equal to 2 to the x. Exponential growth or exponential decay? How do you know it's a growth? Very good. That 2 is bigger than 1. So if that base of that exponent, that base of the power, is bigger than 1, it's a growth. If it's between 0 and 1, it's a decay, right? All right. Now, so this is a growth. Did it have any asymptotes? You remember what it looked like? Did it go through, what was this point right here it went through? What? 0, 1. Okay, and it looks something like this. Okay, so it's asymptote, yeah, it's right here, and yes, you're right, it's y equals 0. What's his domain? Awesome. And what's his range?
0
Okay. All right, now we're going to talk about this function's inverse. Okay? Now, you know how to find an inverse. How do you find an inverse? What do you do? Okay, switch the x's and the y. And this is an exponential. Now, what makes an exponential? An x as an exponent. All right? And his inverse is a logarithmic. Oh. Yes. Okay, his inverse is a logarithmic. Now look, I'm not going to go into a bunch of depth because we have some other things to learn and I just don't have time. We're running a little behind. But I do want to, I want you to understand what a logarithmic equation looks like on a graph and where it comes from. Okay? The reason we have logarithms is because they help us with exponentials. Alright? And exponentials we use a lot in life. So, here we go. Y is equal to log base 2 of x. That is his inverse. Okay? That is his inverse. Now, is he going to have an asymptote? What's it going to be? Oh, there you go. Jody switched the x's and the y's. So instead of y is equal to 0, it's going to be x is equal to 0. Okay? Instead of going through the point 0, 1, what's he going to go through? There you go. Alright? Here's what it's going to look like. What's his domain going to be? Ah, look at that domain, people. Where's that thing? Is it over here? 0. He always starts right there. 0 exclusive to what? Positive infinity. What's his range? Now, do you see the relationship? You see what happened? Switch the x's and the y's, guys. His domain became what? His range. And his range became his domain. Okay? What about a graph? Does anybody remember what inverse functions, what they reflected over? What? Y equals x. So if you drew the y equals x line, hey, who is it, a class? No. How much paper you got me? This what? So, does that, you see if you folded it on that pink line right there? Do you see that yellow would land on top of that blue, right? And this blue asymptote would land on top of that yellow asymptote. Those are inverses of each other, okay? All right. I'll come back later, not today, but we'll come back later and talk about logarithms and stuff like that. I'll explain to you exactly what they are. It's always the last thing that we do in here because it's really kind of cool and it's fun. A little weird, a little different, but it's not hard, okay? So, yes. Well, you know. So, let's see. Did we talk about this yesterday? Did we talk about this formula? I might have used different letters. No? Okay, so let's talk about this formula for a second. This A is my ending amount. The A is my ending amount. The P right here is my beginning amount, my initial amount, what you start with, okay? This 1, this is a 1, all right, plus or minus. You can't, it's not going to be plus and minus. It's either plus or it's minus. This R right here is going to be my rate, and it will always have to be expressed as a decimal. Now, what's it going to be given to me as? No, a rate. A percent. Yeah, it's going to be a percent, and then you're going to have to convert it to a decimal. How do you convert a percent to a decimal? Move your decimal place. Which way? To the left. 2 places, because it is out of 100, and 100 has 2 zeros, so you move it left 2 places. This T right here, this T is my time, and it will always have to be in years. Okay? It will always have to be in years. Now, if by chance, they're probably not going to, but if by chance they gave it to me and they said, in 5 months, then how would I have to put it up here? No. Over 12. 5 months out of 12. That's going to put it as a year. Okay? 5 months out of 12. All right. So let me show you when you're going to use this. You're going to use this if you have something and it either increases in value or decreases in value. Now, let's see if you know the word I'm thinking about. All right? If something decreases, let's say we bought a tractor, okay? And we brought our tractor home. And then every year, what happens to my tractor's value? Yeah, but what's the word? It starts with a D. It depreciates. Very good. So another word for decreases is depreciates. That means it goes down in value. Okay? Depreciates. What happens when it increases? Like, what if I went and bought a 67 Corvette? Is he going to depreciate in value? No. He's going to what? What's that called? What does it mean to increase in value? He doesn't depreciate, he appreciates. And I don't know what the spelling is, y'all.
I would assume 2 P's. 63 is so much bigger.
I just picked a number. Okay? All right. So these are some of the words. Now, if something increases in value, well, my formula is going to be A is equal to P times 1 plus R raised to the T. If something depreciates or decreases in value, it's going to be A is equal to P times 1 minus R raised to the T. Okay?
Okay, quick question. Why didn't they just choose, why does P equal beginning?
It's what's called your principal.
Okay.
Okay? It'll make more sense. It's called your principal. Because this really, to me, you don't use this formula a lot with money and stuff, but the formula that we're going to learn later on that deals with money, it is that we're going to use the same letters. Okay? All right. So this would be something if you bought something, like an antique or something like that, then what's going to happen to an antique? Is it going to appreciate in value or depreciate in value? Appreciate, okay? And so, and it's going to, think about how, if it appreciates, that's an exponential growth or decay? Growth. And so think about how its value is going to grow. It's not going to grow a whole lot at first, but once it gets past that, how old does a car have to be an antique?
No.
15 years.
15?
That's what the kids told me this morning. I don't know.
No.
Okay. Okay, so 30 years. I thought 15 was kind of, like, 15?
15
Like,
is the definition for a classic, but
oh,
it's not any car.
because Tanner watches the car channel all the time. All right, so, and then what happens when it gets to be 30 years old? Then it's going to go up exponentially in value, okay? Now watch this. Let's say we buy a brand new car, okay? A brand new car. Here he is up here. You drive it. You live right next door to the car lot. You drive it off the car lot and into your driveway. What happens to its value? Whoosh! Okay? Why? It only has a quarter of a mile on the odometer. Why did it go down so much? That's right. And it's no longer a new car. It is a used car. It's a previously owned car. Okay? Yeah. So that's an exponential decay. All right? Once it gets to a certain point, like my car was, then it can't decay much, its value, because it's worth so little, right? So that's the way it goes. All right. Now let's talk about another one. Let's talk about compound interest. No, I don't think so. But we got more than my husband thought we'd get, so I'm okay with it. All right.
What about, how would you, what would be the equation, like, say you have a car, you drive off the car lot, it decreases in value, but then 30 years later you sell the same car, and then...
That depends on how well you take the condition of the car. Okay, like they were talking about, like my car was, I don't know, 12 years old, 13 years old, and when I got rid of it. And was it getting ready to appreciate in value? No, I don't think so. It had 200,000 miles on it. And, was it a nice car? Yeah, it had all the stuff on it. But we drove it all the time. So it had way too many miles. It was, well taken care of till my mother smashed into the back quarter panel. All right? So that cost me $500. They said, we can't give you the full value because you have a big dent in the back quarter panel. I'm like, yeah, my mama did that 2 weeks ago. So anyway, it depends on what kind of car it is and what kind of condition it's in as to whether it goes up or down.
Would the graph be different?
No, it would just be at different time periods. Okay? All right, here's compound interest. Here's the formula. A is equal to P, open parentheses, 1 plus R over N raised to the NT. Okay? So let's talk about what all these things are. What is A? Ending amount. Okay, that's why I like to use these letters, even though maybe in the book they might have used a different letter. What's P? Initial or beginning, however you like to say it. It's your paper and your notes. Write them so you understand them. Okay? What about this R?
Rate.
That's my rate. How? As a decimal. Okay? What about, let's talk about these ends in a second. Let's just put some arrows to them. We're going to talk about them in a minute. What about this T? Because we know that one.
Time.
How?
Year.
Very good.
So if it was like, if they gave you months, you would have to put it in.
If I gave you months or anything, you'd have to put it into years. Okay, let's talk about this N. This N is the number of compounding. The number of compounding. Not hashtag compounding, okay, but the number of compounding. So, first of all, let's make sure we got some verbiage with that, whatever that is, right? Because some of y'all are like going, what? So this is going to be the word, and this is going to be the number that it represents. All right? So this is how often something happens in a year. All right? How often something happens in a year. So if I say annually, how often did it happen in a year? One time. Okay? If I said semi-annually, very good. If I said quarterly, very good. If I said monthly, okay. What if I said weekly? Very good. All right, now here's the one that messes people up. This is the one you miss. Okay? So, what if I said bi-weekly?
Every 2 weeks. It would be every 2 weeks.
And this, you see what's happening, okay? I got half and half. I got half the kids going, I think that's what? Every 2 weeks, which would be what? 26, okay? And then some people are saying that's twice a week, so that's 104. Now, bi-weekly, that is every 2 weeks. Okay? Bi-weekly means every 2 weeks. If you're paid bi-weekly, y'all, nobody's going to pay you twice a week. Okay, that's way too, that's a lot of hassle. You think about it, you're going to have to hire a bunch of people just to write checks and cut checks for people. Okay? So, this is 26. Bi-weekly is every 2 weeks. A lot of people are paid bi-weekly. And the other one is daily. We're going to call it 365. That's what they call it, 365. All right, so let's talk about what compound interest is. All right, before compound interest, you have what's called simple interest. For instance, if I put $1,000 somewhere and I made 2% and I left it in there for 10 years, then at the end of 10 years, they would say 1,000 times 0.02 times 10. Interest equals principal times rate times time. And that would be how much money I made on my money. Everybody understand? Okay, so now they have this thing called compound interest. Compound interest, and look at all the different ways I could compound it. Let's say we compounded it quarterly. How often is quarterly? Every what? Every 3 months, right? 4 times a year is every 3 months. So here's what they would do. I put my money into the bank, and then at the end of 3 months, they would figure out how much interest I had, and then they would push that interest back into my account. So then the next 3 months, the next quarter, would I make more interest? Yeah, because I have more money in the bank. You see what I'm saying? And then the next 3 months, I would make even more than I made the second one because they pushed the second quarter's interest. And then the third quarter's interest. And then the fourth quarter's interest. And then you're in the second year. Do you see what I'm saying? So what would you rather have your interest compounded quarterly or monthly? Monthly. Because then instead of waiting at the end of 3 months, they're going to, at the end of 1 month, say, look, this is how much money you've earned. Okay, in interest, and I'll put it back in your account. And then the next month, you'll make more interest. And then the next. Do you understand? Now, it seems really easy, and so it seems like you go, well, excuse me, I want you to compound my interest daily, please, right? Because that will be at the end of every day, someone goes over there and says, oh, you made this much money, we'll put it in your account. And then the next day you make more, right? But it's not going to be that easy because they're going to change the rate on you, okay? So that's just something that you're going to have to understand and know about, and you'll have to know which one works best for you, okay? So we want to teach you how to find all that so you can have the skills to see what's best for you. All right. Do what? $1 trillion. All right, that's right. And then you can be like me, right? So, I didn't really, y'all know that, right? So, this is it, okay? This is the way you do it. So, let's work some problems. Let's work 2 problems, all right? Here's the first one. Now, I will tell you this, okay? I'm going to give you this formula and that other formula this one right here. I will give you both of these formulas on the board. Okay? Both of them I will put on the board. But now listen, here's what's happened in the past. All right? We always learn. It's nice to learn from other people's mistakes, right? So evidently I had a kid who wasn't paying attention during class. And then the day they took the test, I was out that day. All right? Which to me is not a big deal because do you need me to take a test? I'm not doing it. All right? You're doing the test. I'm not helping it or anything, so it's just all on you. So then the next day after the test, he comes in here and he said, Miss Davis, I failed that test. I'm like, how could you fail the test? I put the equation on the board. He goes, I didn't get any of them right. I'm like, you have a calculator. Why? And he said, I couldn't figure out what L was. Yeah. And that's how little attention he was paying to me when I was teaching in class. He didn't even know that was a 1. He thought it was an L, and he said, I looked and looked. I just couldn't figure out what it was. And I go, well, that's because it's a 1. Okay? So at least pay close enough attention that you know what everything in this formula is. Because while I will give you the formula, am I going to tell you what it all is? I'm not going to, people. Okay? Because next year, you won't even get the formula. Okay? Next year, you'll have to know it. All right, so here we go. Yes.
What's the title of this thing?
We're still on 7.1, and we're just going to work one example from there, and then we're going to work one example from 7.2, okay? And then we're going to go and start on 7.3. Whoa, I know. It sounds crazy, but it's not bad. All right, so here is example 4 from 7.1. It reads like this. Oh, sorry, it's really example 5. You deposit $4,000 in an account that pays 2.92% compounded quarterly. Okay, now, first of all, I want to tell you something. Sometimes they'll put these words in here, and I don't want them to mess you up. Sometimes they'll say an account that pays 2.92% annual interest compounded quarterly. Don't worry about that annual interest. That's not the annual that we were talking about here. These words are coming after the word what? Compounded. Okay? So as soon as I see the word compounded, I'm like, oh, that's that 1 plus r over n raised to the nt. Okay? So this would be the word you were looking at. Compounded quarterly. How much do you have in 10 years? All right, so here's your formula. A is equal to P times 1 plus R over N raised to the NT. All right, we're looking for A. Everybody agree with that? Mm-hmm. What's P? 4,000. Your principal is normally it's either how much you invest in something or how much you borrowed. If you borrowed $4,000 from the bank, they would call that principal also. All right. If you put $5,000 in the bank, they would call that 4,000. So 4,000 times 1 plus what is my rate?
0.0292.
Yeah, 0.0292. Okay. Now, y'all, let me show you how crazy what you just said was. First of all, are you going to get 2.92% interest at any bank around here? No, the bank's not paying that high of an interest rate. Okay? You're not going to get you probably won't even get 2%. All right? Now, you just told me to put 2.92 right there. What were you saying you were getting? 292%. People, if you're making 292% on your money, you're going to go to jail. It may not be today or tomorrow, but sooner or later you're going to get caught because you're doing something illegal. Do you understand? Let me tell you this. If this sounds too good to be true, it is too good to be true, people. Okay? All right. What's N? Why? Very good. Raised to the 4 times, what's T? 10. Now, y'all listen to me. Do not put this stuff in your calculator separately. Just pop it in your calculator. He will follow all the right rules. He knows those. Okay? Just put 4,000, open parentheses, 1 plus. If you want to make the fraction right here, you can. I'm just going to go 0.0292 divided by 4. Close the parentheses, raise to 4 times 10. Okay, you got it? What did y'all get?
$5,350.73.
Okay, so this is how much money I have, right? Y'all, that's my ending amount. $5,350.73. How much money did you make? What's your interest? Okay, so $1,350.73. How long did it take you to make that money? 10 years. That, okay, so remember what we talked about yesterday when we talked about this? That is a very long time. But remember how we talked about our little retirement fund, right? And we said little money makes little money, okay? $4,000 is not a lot of money in a retirement fund, okay? If you're 45 and you have $4,000 in your retirement fund, you've got a problem. Okay? Remember how we talked about $1 million, right? And I know that sounds unattainable to you, but it's not, guys. It's not. If your company is matching and you're putting money and your money's growing, then that's not, all right? So think about you're over here at 40, all right, and 45. And instead of $4,000, what's it going to be? $400,000. You see what I'm saying? $400,000 is going to make good money. You see? What did your 1,000 just turn into? 100,000. Okay? You understand? Big money makes big. That's why you have to save. That's why you got to start saving at the first. Don't wait till the very end. You'll be in trouble. All right. So there it is. Anybody got a question about it?
Yeah,
Okay.
you put 400,000 and you're getting over $250,000.
Yeah. You make big money makes big money. Little money makes little money. All right? Remember how y'all? I told y'all that saying yesterday, right? The rich get richer and the poor don't. Okay? Why? Because the rich have a lot of money to invest and make money off of. Yeah, it's easy for them. It's harder for us poor people. All right? Okay, so here we go. Here's my next one. This is 7.2, and this is example 4. Okay? And we're not living here in southeast Texas. We've moved to Colorado. And we're going to buy a snowmobile. I've never ridden one. We didn't ride one when we went to Colorado. Oh, because Becky got broke. We didn't get to play. She was out for a whole day and a half. So that's what happens when you go 95, when there's 5 signs that are 5 feet tall, and they say, slow, slow, slow. So she ran over her sister, going no less than 90 miles an hour. Yeah. All right, so we bought a snowmobile for $4,200. Okay? It decreases in value at a rate, not rot, at a rate of 11% every year. What's its worth in 6 years? What's its worth in 6 years? Which formula am I going to use? Okay. It's not the compound, is it? Now, this is not compound. Okay? So this is the A is equal to P times 1 what? Minus R raised to the T. Very good. So A is equal to, what's my principal?
4,000.
That's its beginning amount, guys. 4,200. 1 minus, what's my rate? 0.11. What's my time? 6. Look at this. What's 1 minus 0.11? 89? 0.89, right? Okay, look at that number. Exponential growth or decay? Decay. Between 0 and 1. Okay, very good. All right, put that in your little calculator. Tell me what that thing's worth. 2087 what? 32.
Okay, so I don't think
Okay, now is this an exponential?
Yes.
It's an exponential decay, guys. What's changing all the time? Is the rate that it decreases changing? No, that's not changing. What's changing? How many years? There's your x right there. Okay, an x in the exponent, exponential decay. Let me ask you a question. Did it lose more value its first year or its 5th year? Very good. We've already talked about that. Okay, we already talked about that. All right, good deal. Now, we're going to do one more thing, and then we're going to be through. We're going to talk about that number right there.
the number E.
The number E.
Something very
The number E. So, yeah, you should have seen Bradley's face. He was the only person, he was just listening and writing, and he was writing, and as soon as I said the number, and he looked up, then he went, like, what? What? It's the number E, and it is called Eulers number. You know you're important when you got a number named after you. Eulers number. Now, did I say Bueller? Yeah. Did I say that? No, that's what. Haven't you ever seen that?
Well, okay,
No, it's not. It's not country. It's that Stein guy. What's his name?
like the last
Yeah, and he goes Bueller. That's the way he checks roll. And Bueller skipped that day. That's Ferris Bueller's day off. Bueller, Bueller, and he's not there. He's in bed. All right. So, but it's not Bueller, guys, because every time I say it, that's what the pre-cal kids are all like Bueller. And I'm like, no, it's Euler. Euler's number. Okay. Now, let me show you where Euler found his number. He discovered this number. He did not make this number up. Okay? So, first I'm going to go to y equals.
He didn't make up.
Look, see this right here? I put this equation in here. 1 plus 1 over x raised to x. You don't have to know this part, guys. Okay? You don't have to know this. It's not a big deal. I'm going to go to second and table set. I'm going to start my table at 0, and I want it to go by 1,000. Normally, what's our table go by? 1. Okay? We make it go by 1. Now, look at my table. Look at that. 6, 9, 7, 6, 7, 8, 7, 9, 8, 0, 8, 1. And I'm over in the tens, hundreds, thousands, 10,000s. Is it changing a lot? Yeah, I'm not changing a lot. Oh my word, look, I'm still at 8. Oh, there, at 11,000 he changed to the 2. When do you think he's going to change to a 3? There he is. 43,000 he changed to a 3. So he's not changing much. So you could say that this graph is approaching that number, right? That's what that means, guys. He's getting closer and closer and closer to it. So, what do we approach? What are they called? Asymptotes. So that's what that asymptote ends up being, is Euler's number. Okay, that's what all these graphs, that's what these curves are approaching. Euler's number. So here it is right here. We just saw it. It's about, now is it exactly? It's about 2.8173. Oh, it is on the calculator. Is it an irrational or a rational number? It's irrational. It's just like what? Pi. Y'all, it's just like pi. Okay? So, 718. Oh, so it's 72? 71. Oh, sorry, I got the digits backwards. 2.7183. Sorry. All right. 2.7183. I said 8173. Sorry. Sorry about that. All right. So, but it is where? On my calculator, right? I can go second and right above the divide on the left. There's my E. Look, this is my third time to look at it. Okay? E. That's an emotion. What? That's times 10. Yeah, that's times 10 to a power. All right, that's what was scientific notation. Okay.
What's capital double is?
That's times 10 to a certain power.
Oh,
Yeah.
Oh, I thought they said 1E, and I was looking for.
Well, actually on your calculator it'll only write 1E, but on the button it says 2. All right, so why in the world do I need to know Euler's number? Because if, by chance, you get not just compound interest, but what if I could compound that interest every second? Would you want that job? Oh my word. Since
I can't spell, okay? I started with D instead of U.
compounding. Compounding continuously. Compounding continuously. Now, if your interest is compounding continuously, that means they're always figuring it up and pushing it back in your account. Always, always, always. Here's the formula. A is equal to P. Oh, it's starting out the same, isn't it? But it's pert near not the same. Y'all get that in a sec. There it is. It's called the PERT formula, people. Okay? It's called the PERT formula. It is P times E raised to the RT. Okay? So let's just see. What if we took that same $4,000 that we invested in that account? What was our interest rate? 2.92%. But this time it's going to be compounded how? Yeah, y'all, you only use this formula when you see the word what? Continuously. If you see quarterly, semi-annually, monthly, day, whatever, don't use the PERT formula. It's only when you see the word continuously. Is that thunder? No? Okay. Oh, dadgummit. All right, compounded continuously, and we're going to try it for 10 years, right? Boy, are we going to be wealthy or what? Okay, 10 years. All right, let's do it. A is equal to, what's P? 4,000. Times E, raised to the, what's R? What's T? 10. Are we wealthy?
30-year-old.
I'm going to say 5,356 41 or something. All right.
You gained $6.
So I gained about $6, right? But now listen to me. Remember, y'all listen. Listen to what I'm saying. That's at $4,000. Okay? That's $4,000. Little money makes little differences. Big money makes big differences. You see what I'm saying? Okay? So you got to start, everybody has to start off small, people. I mean, unless you came from wealthy parents or wealthy grandparents, we're all starting off with the same amount of money. Okay? So you're going to start off just like everybody else and have a little bit of money and make a little bit on it. Okay? All right. Anybody got a question? Okay. So I'm fixing to give you a worksheet. When's it due? Tomorrow. It has 8 problems on it. Okay? Oh, I forgot.